Hello everyone, welcome to the solution of JEE Advanced 2025. There was a beautiful question on rotation and SHM combination, and we are going to solve this question within 20 seconds using some tricks. So let us say what the question says. Basically here it's given that there is one small disc which is being connected with a spring, and it is restricted to roll or rotate along the periphery of the bigger ring of radius r, and the disc radius is small r. So it's given that the bigger radius is very larger than the smaller radius, and we need to calculate the what is the angular frequency of this disc. So if you try to solve it generally, so it is quite hard and lengthy. So but if you assume that since r is greater than small r, you can say that, let's say my r is tending to infinity, so this surface becomes flat. So this is equivalent to a simple spring connected to a disk. So this is a very standard way of SHM of solving. So now it is no slipping means this point is at rest. So I can consider this body as a pure rotation SHM about this fixed point, and I can write its energy and differentiate, and I am going to get directly the angular velocity of this disk. So let me write the total energy, which will be half kx square plus half I about instantaneous axis of rotation into omega square should be constant. So here my x will be r theta, like if I deflect this disk by an angle theta, so that displacement x will comes out to be r times theta. So substituting that here, it gives me, let me write it here, so it will be half k r square theta square plus half moment of inertia about center is mr square by 2, plus you have to use a parallel axis theorem here, so that will comes out to be 3 by 2 mr square into omega square should be constant. So from here you can see that if I differentiate this equation, so that is basically half k into r square, so which is basically here this r will be my radius, okay, small r, it is not capital R. So from here half r square, r is constant, theta ka derivative is 2 theta into omega, plus half 3 by 2 mr square into 2 omega into alpha equal to 0. From here we are going to get the beautiful relation between alpha and theta, which will comes out to be, you can see this half is getting cancelled out, omega is getting cancelled out. So from here you can see that what we are getting is this 2 also I can cancel. So from here it is even r square is getting cancelled out. So k is equal to minus 3 by 2, and there is one theta here, alpha, m times alpha. So from here I am getting alpha as 2 by 3 k by m into theta. So here omega will be under root of this, and the 2 by 3 factor is with k by m. There is only one option which is matching, is option number A. Hence the correct answer for this question is option A. Hope you enjoyed this question solution. Please like, share, subscribe, and wait for the further solutions.